Hello everyone, this is my IoT project which I have to realize on the Proteus software. So before going on the simulation, firstly I have to understand that what is the code written behind this project. I have to use Raspberry Pi microcontroller and I have to upload all this code on the Raspberry Pi, and according to this code Raspberry Pi send the data to the LCD, and this simulation has been done. Okay, so firstly I have to go down the coding section. After that I have to go on the simulation section. Firstly I have to import all the libraries, because we know that the for accessing the pins of the library Raspberry Pi, I have to import this library rpi.gpio, as a GPIO is a basically attribute to this library. Okay, because with the help of this GPIO variable, I have to access all the parameters in this library. Okay, because I have to use mainly delay constant. So for the delay constant I have to import the times, and for the SPI communication I have to import this library. Okay, here I have to define all the pins of the Raspberry Pi. The D0 to D7 are the data pins, and for the buzzer I have to use 32 pins. LED I have to use pin number 33, and for the pump, simulating the pump, I have to use pin number 36. This file channel 0, basically I have to use channel 0 of the analog to digital converter. So I have to collect, yeah, in, I have to collect it on the soil channel variable. Okay, initialize in the this variable. Okay, now come on the this line. So for removing unwanted warning, I have to use this function where false is taking as a argument in this function. Okay, gpr.board means that I have to using basically this pin number according to the pin number of the Raspberry Pi. Okay, so for use I have to use gpr.board as an argument. If I have to use according to the GPI numbering, like GPI 17, GPI 7, then I have to use the gpr.bcm as a argument. Okay, but I have not using, so I have to use gpr.board function. Okay, so for opening the SPI bus, I have to use this two line of code, spi.open, for opening the bus, and I have for accessing all the attributes in the library spi.dev and spi.dev, I have to give an attribute to the SPI variable. Okay, now we know that our LCD working in two mode. First one is command mode and second one is data mode. What is a command mode? In the command mode, basically I have to load all the bits in the form of command. Okay, and basically then the because I have to send two character of the hexadecimal, and these two character of hexadecimal will convert it into the 8-bit form, because one hexadecimal bit is represented by the 4-bit and other hexadecimal bit represented by the 4-bit. Okay, so we have to load on the two D0 to D7 pins. Okay, so how did the command work? Basically, enable pin. The enable pin trigger the LCD to read the data present on its data pins D0 to D07. When transitioning from logic high to logic low 0, where the enable pin is set to the 0 logic, low 0, and the LCD execute the command or process the data present on the data pins. Okay, the typical sequence of operation as follows: set RS to the low to the enter command mode, and set data pins D0 to D7 at desired binary value representing a specific command. Example: clear, display, move cursor, etc. Set enable pin to the high to enable the LCD to read as a command. Okay, and set enable as a low to execute the command. Similarly, to send the data character LCD, set RS to the high to enter the data mode, and set data pins D0 to D7 to the binary value representing the character to display. Okay, and now set enable to high to enable the LCD to read the character data, and set enable to the low to display the character data. Basically, enable pin used to if enable pin is high, then we have to read the data on the data that has been loaded on the data bus. Okay, and if the enable pin goes to the low, then we have to display the data. Okay, so so you can see that in this program we have to define the function. Okay, so here d0 to gpr dot output function take a argument uh, firstly we have to take the argument that which pin we have to access and what is the status of the pin, if the pin has been low, if the pin has been high. So status of the pin defined by the command mode, but basically the command data that I have been given argument, okay, in this function. So it lists that if the this command mode is equal to uh, 080, okay. So we know that the in 80 the first pin goes to high, basically 01 first pin, because in the 8 bit mode it will be yes, first the most significant bit will be goes to high, okay. So we have here we have to use AND operation. So what is the use of the AND operation? AND operation help me to masking the particular bit, okay. So if I have to masking the particular bit, then we have to access the first the most significant bit of the CMD, okay. Let's assume that the if the we have to masking the first MSB of the CMD, okay. So here to use bitwise operation 2, because we have to, because if when I have to masking the first bit, then it will masking the only the particular bit, the bit that after that bit will as it is, okay. No changing in the status of the remaining bit are not changing. So for because I have to use only one bit as an argument in this function, so we have to use bitwise operation, okay. So we have to use we have to, because we have to masking the second bit, so we have to only need only one bit, okay, to basically to shift the only one bit, okay. So we have to use one, and after that we have to use two, we have to use three, we have to use four, we have to use seven, because here we have to masking the eighth bit, okay. So we have to shift the eighth bit to the last position, so we have to so for that we have to shift the seventh, okay. We have to use 7 times, okay. We have to shift it 7 times, so we have to use we have to write as a 7 at this position, okay. So similarly this function had work that the GPI that output pin take firstly the pin number and the pin status, okay. So we have to set this pin status in this form, okay. Now as the same thing that will work this same thing this in the command mode, that basically the operation that we have to use in command mode, similar operation we have to use in the data mode only. The minor change has been we have to see that a minor change has been inputted in this function, that here the RS pin goes to the high, okay, the data mode, because we have to on this position we have to work on the data mode, okay. Now firstly we have to initialize the cursor, so we have to give the argument, we have to basically the call the this function lcd that command function, we have to call the command function. So to the basically we have to ready the lcd as to work in the 8-bit data mode, then we have to display on cursor, basically we have to set the cursor on the first mode, okay. Now for the printing message, because we have to print the because message contains a string, okay, and in the string there is a many character on an lcd there is a lcd have not any in technology to print the string directly, okay. So we have to use in the illustration manner, we have to print character one by one in illustration manner, okay. And we have to use here delay times is 0.2 seconds, okay. Now for fetching the data from the uh, ADC, analog to digital converter, okay, we have to use this function, okay, that what is the data on the channel yes, what is the data on the channel, okay. So for fetching the data, firstly we have to call this function spi.xfr, okay. So what does this function do? This function basically convert, firstly basically this function this spi.xfr function take a argument as a list of 8-bit data, okay. What is the 8-bit data? As first bit shows that the status, okay, that you have to ready to take the data, okay. So we have to convert this data in the 8-bit data, 8 plus channel, because one 8 plus channel, and we have to shift it at the fourth position, okay, on the left side, okay. And we have to convert into the 8-bit data, okay. And what does this function return? This function return 10-bit data, okay. And here we have to convert 10-bit data into the 8-bit data form, because the data variable only take 8-bit data, okay. So now we have to return this data, and this data will be converted into the string form, and this function I have to use. LCD.print basically used to print the string this welcome. Okay, because welcome is a data, and we have to use LCD.print where welcome is a data. Okay, and we have to use here illustration to print every character on the LCD. Okay, now we have to use illustration because we have to update the soil level. Okay, because we have to update soil level every time, so we have to use while loop. And here the soil level has been printed and the status of pump has been printed with the help of this illustration that we have to use in this Python code. Okay, now come on the simulation part. How the simulation part has been worked. This simulation part basically takes the first string as a welcome string. Okay, I have to start this simulation. Okay, here I have to, here you can see that here the LCD has been on. Now this LCD print the welcome message, and after that it will print the second string explosive data lab. Okay, now it will print the pump status. Now the my swell level is 262. Now you can see that my pump goes on. My pump was start moving and buzzer will be on. Okay, so if this soil level goes beyond the 500 value, because I have to see, you can see that my threshold value has been given to the 500. Okay, so if the, yes, you can see that the buzzer has been started, buzzer has been on. If this value goes beyond the 500 value, then our pump will off. Okay, now I have to change the potentiometer value. Now you can say that the pump will goes to the off according to the soil master sensor. We have to use an inertial motor. The torque of this motor got decreasing. Okay, this is two LED that I have been used in this project. First LED will show the status of the motor, that this motor will be on or off, because I have to use inertial motor, so we will unable to differentiate that after the when the motor goes to the off. Okay, so I have to use two LEDs. First LED show the status of the motor, and second LED show that my motor goes to the off situation. Okay, okay.